We did this yesterday. So I'll do it again. This is x cubed. It's an odd number. The opposite of cube is the cube root. This is the symbol for root. So this is the cube root. If x cubed is negative 64 and we want to know x, we have to do the opposite of this. We have to take the cube root of negative 64. And if it is a negative number, we know that the answer is also negative. Because negative 4 times negative 4 is positive 16. Times negative 4 is negative 64. Tick. So the opposite of cube is cube root. Now, of course, the opposite of cube root is cube. Yesterday, I squared it and doubled it. Well, yeah. If you do so much in a day, that happens. So, I'll do it again. I changed the 3 into a 4. The cube root of 4x is 6. So you have to think that 4x is 6 cubed. The opposite of cube root is cube, which is 6 times 6 times 6. That happens to be 216. So x is 216 divided by 4 is 54. So this topic is equations. And in an equation we all have to always find the value of the mystery number. Often xy, sometimes a, b, doesn't matter. In this case the unknown is called a. 4 times this means times, it's left out, mathematics is shorthand, is 12. So you think, of course, that the 4 cancels against the 12. And a negative 3 is then 3. Negative 3 on that side is positive 3, so a is 6, step by step. First get rid of this, then get rid of this, and we know the value of this. Here, 4 goes into 12. 12, another way of saying is, 12 is divisible by 4. Now, negative 4 is not divisible by 3. Evenly, I mean. So we have to first work this out. This means 3 times whatever is in the bracket. That means 3 times the x and 3 times the negative 2. So not take away 2, no. 3 times negative 2 is negative 6. This is unattached, this is attached. I'll first get rid of the unattached. So we have then positive 6, negative 4, the positives are winning by 2. And then we divide it by 3. So this is the fraction. X is 2/3. Equations again. So we have to work this out. 5 times this, negative x negative 3. One of the biggest mistakes in HSC is, although they'll learn 2 negatives make a positive, nah. You know why? It's not good to learn a rule if you don't see the parts. I teach you to see. The first thing is see before you do anything else. You say the signs are negative. So 5x negative 10 negative x positive 3, and that's where it always goes wrong. Five x negative x is 4x. Negative 10 becomes 10. Positive 3 becomes negative 3. So the result is 7. Times by 4 is division by 4 here. So x is 7 on 4. And that is an improper fraction. How many 4s in 7? 1. How many left over? 3. And the name stays the same. In primary school, I taught you all fractions in 4 seconds. When we have unknown letters, it is still a fraction. So the recipe is still times, 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 and times. So you have to look first, because this line is negative 20. So we start writing times, times, times. 4x negative 20 equals 3x positive 18 and so 4x negative 3, this goes to that side, so that becomes x, and positive 20 and positive 18 is 38. Times, times. This line equals that line. There's 2 positives, A, and 5 negatives, so the negatives are winning by 3. So this turns into negative 3A, and because the signs are negative, different, the result is negative. So with division and times, we have this one rule. If the signs are the same, it's positive. The other one is not a separate rule. No, because that is the result of the first rule. There's only one rule. The signs are not the same, so the answer is negative. Positive 13x goes to that side to bring the x's together. 17 take 13 is 4x. Positive 35 goes to that side, and there's 19 negatives, so the positives are winning by 16. Multiplication here is division here. 16 divided by 4 is 4. To get rid of this root sign, this is square root, but the 2 is not mentioned. So this is the square root, but the 2 is not mentioned. The others are always mentioned, 3, 4, 5, 6. So we cancel the square roots on that side. In other words, we square this and we square that. So it's not really this cancels against that, that's not really. We square it, and then it becomes 6x negative 4. We square it, and that becomes, and then it looks much nicer. 6x negative x is 5x. That becomes 20. 16 positive 4 is 20. 5x is 20. You do not write that down, you only think x is 4. We say in mathematics we have to get rid of this 3. It's a funny expression. We better say this is division by 3. To get rid of it, we have to multiply by 3, but if we multiply this by 3, we have to multiply the whole lot by 3, not just this one. So if we multiply the whole lot by 3, 3x, negative x, that looks much more interesting. And 3/8, 8, 3, 24, we learned it in 24. 2x is 24, x is 12. You only think this and you write this. No such thing as show the necessary working. How can that be necessary? Pythagoras lived 3,000 years ago. And he discovered something extraordinary interesting. I say Pythagoras. Of course, a teacher who has been going to teachers' college, he says Pythagoras' theorem. I'm a Dutchman, I can't say this. What's nonsense to add this word theorem? Pythagoras. Da. Pythagoras discovered if you have a right triangle, then he discovered that the square of this one plus the square of this one equals the square of that one. Later on I call this capital H because and small h, because the h for this is the longer side is hypotenuse. So when we do Pythagoras, we use the hypotenuse. That seems simple, but of course it isn't. A squared plus b equals c squared. 3,000 years ago. And so then he discovered the famous triad. A triad is a group of 3. 3, 4, 5. And the double 6, 8, 10. 5, 12, 13. Is that funny? These are next door numbers. 7, 24, 25, next door numbers. And peculiar. What's more peculiar is this is the double of that, This starts with 5, 7, 9. This is extraordinary. After 50 years, this is the first time I actually see it myself. So my mind is still thinking, because I'm not like sardines in a tin. Next door numbers, 5, 7, 9. Next door numbers, next door numbers, next door numbers. That's amazing. That means that 3 squared plus 4 squared. 3 squared plus 4 squared is 5 squared. This is 9 and 16 is 25. Yes. 25 and 144 is 13 squared. This is the double of that. 7 squared plus 24 squared is 25 squared. This is amazing. Pythagoras. Forget about the word theorem. That's a pedantic, typical school. It looks pedantic to think, yeah, this is a very important subject. Well, so I'm only working with the letter H because opposite is the small h, hypotenuse. That makes sense. So you have to visualize that. In books you have, of course, 20 of triangles upside down and whatever without names. So as soon as you have to pick out one, you put your own names. A, angle B. So opposite B is side B. Opposite A, it could not be easier. BB, AA, HH. There's only 3 possibilities. How can that be difficult? This is the biggest one. So instead of h squared is a squared plus b, I straight away put it in the calculator. So this one is the square root of that square and that square. So when you start with h, you have the sum of these two. And because the a is smaller than this, so then you have, there's only 3 letters. So if you start with a, you have the h squared, and there's only 1. And because this is a small one, it's negative. And if you start with the b, h squared negative, how can that be difficult? When you want the hypotenuse, the square root of the sum of the squares. If you want a small one, it's h squared negative b squared. So you put it in the calculator. Square root sign, negative. So A has the AB, A has the H in the B, and the B has the H in the A. Negative because this is the biggest one, so these two are smaller. So imagine you're given this, and again you put your own subject. You know, you have only 3 letters, A, B and H. And small h, now the little a is 3.2. And the little b is 7. So we want to know what the h is. That is the square root of the... So h is square root, so we don't put first down a squared plus b squared in nana. in school, they always start with the, now, I want to know what this is, so I'll start with this. And that is the square root of 3.2 squared, positive 7.3 squared. So you put it in the calculator. This root sign, this square, that square equals that. By calculator. Here we have to find out what the A is. Now we know the H and the B. So it's again this square, take that square, calculator, square root, this means equals about 4.6 because it keeps on going. Pythagoras in one lesson. So, we have now learned that we're talking about the square root of 6. So 5 of those, negative 1 of those, that's 4 of those. 3 2s are 6. Root 2 times root 6, 3 is root 6. 8 divided by 4 is 2. Root 15 divided by root 5 is root 3. No problems. 2 of those plus 3 of those is 5 of those. They are called surds. They are actually absurd numbers. So that's what it means, absurd numbers. And I started with Pythagoras because I do Pythagoras here again. If this is 1 and this is 1, 1 square plus 1 square is 2. So this is the square root of 2. In a drawing, it looks precise, but of course, the thickness of your pen and your pencil and God knows what, it looks accurate, but it is actually not. Now in the calculator, root 2 is 1.4142135662 and it goes endlessly. So that's why they're called absurd numbers. They leave the ab out and it becomes surds. So if I keep this and then I do a right angle here 1, then this square plus this square is 3, and this is then the square root of 3. So actually in the drawing it's precise, but of course if you look with the magnifying glass, your pen, the pen is already a tenth of a millimeter, so it can never be, it looks exact, but it is not really. In the calculator, it starts here and endlessly 08, 08, 08, 08, 08. That's why they're called surds, absurd numbers. This is almost my favorite. Linear equation. That means the drawing is going to be a line. And when we have linear equation, we have to do with an x and a y. So as soon as you see this, you think linear equation. In schools, of course, they spend 5 minutes 1, 2, 3, 4, 5, 6, negative 1, insane. Because to draw a line, you only need 2 points. But you might make an error, so we have a third one to check. How do you start? Well, we have to substitute numbers. Instead of letters, we have to put a number. And you can put any number. These are the coordinates. They coordinate together. So, the easiest way is to say x is naught. And if x is naught, y is 3. So that's your first naught, 3. So we do that. X is naught, y is 3. So you don't put 1, 2, 3, 4, 5, 6, nah. You measure it straight away 3. Then you say, usually the school tells you, silly, do easy. X is 1. Well, if x is 1, y is 5. It's not difficult. If x is 1, so don't go there, x is 1, y is 5. Not here, because that tells you that this is the height of 5. So 1 and 5. So we have already this. Now we're going to check whether I didn't make a mistake. So I'm going to do a second one. I'm going to make x2. That makes 4 and 3. If x is 2, y is 7. If x is 2, y is 7. So don't go to that line. No, that's indicate that this is 7 height. Ah, yes, we didn't make a mistake. This is called the x line. To the right from north is positive. Well, that makes sense. And to the left is negative. Up positive numbers and down negative. Up and down, positive and negative. Negative and positive, left and right. That cannot be a problem. Now the question is negative 5 naught collinear? So they're asking, is this point negative 5 and y is naught, is that on the line? Well, you can see for yourself. But you can't just say naught. So if negative 5 naught on the line, no, you can see it. But you have to say y. So, y is naught. So, is naught equal to 2 negative 5s? That's negative 10 and 3? No, it isn't. So that proves you can see it and you can calculate it. Is negative 5 negative 7 on the line? Negative 5 negative 7. Negative 7 is negative 10 positive 3. Yes. So negative 5, that's off, so that point is somewhere here. So this one I can show, but this one I have to calculate. So we put this in this equation. This is negative 10 and this is negative 7. Yeah, that's okay. That's the whole theory of linear equation. Sometimes it is called straight lines. Because you also have curved lines. There's nothing else to learn about this one. Okay. We have already done in 3 lessons 46 pages. That's why it's called Maths in Minutes. And you find it in this book. I took on the American spelling because that looks better. Maths and Memory. Barks, that's my name. The discovery method. So I give an example and you see how it is done. So that if you find it, that discovery is an inner process. And that is of course better remembered. An inner process. Steiner said it. It's an inner process, not what the teacher tells you. It goes